Since it's 2:01, should we get started?
Yeah, all right. Hello,
Folks will
everyone. Can you give us a sign on the chat if you can hear us? All right, great. So it's a 2 a.m. in California, 4 a.m. at Chicago time. We're super excited to be here. We have a long agenda, so without further ado, I think we can start. So let me just share my screen and we go to introduction. Right. Or give me a sign. I cannot see the chat, so give me a sign if you can see my presentation.
Yep, that's good.
Awesome. All right. So today we're going to cover Docker for our users. It's one of the topics that I as a data scientist, I consider this topic as one of the most important. I can divide my career as a data scientist before I knew Docker and after. So I think that's a super important topic for reproducibility and folks that are doing production. Raul is the person that drove me to start to work with Docker, so I'm excited to have Raul with me. The agenda for today, so we'll start with kickoff with a couple of admin stuff, and then we will move to introduction to Docker. We go over we will have 5 minutes break. We'll try to have a break within the hour. So 3 a.m., 4 a.m., and 4 a.m. we'll have a longer break, and then we'll continue until then 5:30 Pacific time. After the break, we will come back and talk about Dockerfile, continue to talk about command lines for Docker, and take another break, and come back and talk about Docker with R, and we close up with some intermediate concepts like deploying Docker with GitHub Actions, Shiny with Docker, and other. And we close up with a summary and Q&A. So just a quick introduction. So I'm Rami Crispin. I'm a data science and engineering manager. I love time series analysis and forecasting. That's the main thing that I'm doing. I'm using heavily Docker. I'm an open source contributor. So part of the things that I during the pandemic, I started to do some work related to COVID, created the Corona package, and one of the things that forced me to use Docker is the need to build pipelines and use GitHub Action, and for this process, I learned a lot about Docker. I will hand it off to Raul to introduce himself.
Hi, everyone. So this is Rahul. I'm a data scientist, and again, time series forecasting and anomaly detection is stuff that interests me. I've been doing anomaly detection, particularly on time series, for a while. I find it very exciting. Again, I stumbled upon Docker in my whole journey of getting R in production in the work environment, and I think to Rami's point, it's significantly changed the workflow and the approach towards every project that I do now. So very excited to be here.
Or do you want to cover the polls that we have?
Sure. So folks, in the chat button on the top right, you should see a polls icon. There's a bunch of polls in there. If you could go and answer, it'll give us an idea of where people are coming from, what your experience is with some of these different tools. And I believe the poll should be open to y'all as well. So you should see who else is in the audience. Let's see.
And also, if you can add in the chat
Live.
from which country are you from, and just for fun, what is your favorite animal?
Let's see. Okay, so we had a continent one in there. So we have roughly 60% folks from Europe, 23% North America. We have one person from Australia. Hello. Okay, majority of folks using Intel processors today. We do have a few on Apple M1, so that's going to be interesting. And we'll talk about why when we get to that section. It's an even split between the operating systems, looks like, with Windows leading slightly. Folks do have Docker Desktop installed for the most part. And don't worry if you don't. Again, we'll go over that in a bit. Let's see, experience with Shell, Bash, and command line. Okay, it's sort of a bell curve, if you will, within 4 categories. Similar with experience with Docker. So lots of folks new and with some basic knowledge. No experts, luckily, because we don't think we are experts either. So that's a good thing. All right, great. Move on to the next section. Rami. So quickly, code of conduct. I won't go through here. I won't belabor the point, but there's some guidelines that we have to follow for the workshop. TLDR, be kind to everyone. We have a wide variety of people coming from different backgrounds and experiences, and we'll cater accordingly and pace things out accordingly. Let's see, Rami, and the next slide we had. So engagement model. Again, you'll see there's a Q&A section. So there's a chat window where you're welcome to chat, but there's also a Q&A. So if you have a very succinct question, put it in there, and then we can track it and answer those questions. We have a Q&A at the end of each subsection. So don't worry about of interrupting us. If you want to wait, we'll go to the end, and then we'll have a Q&A, and we'll go through those. If we can't get through it because of time, don't worry. We'll document those and get back to you even through like an issue in the GitHub or something. And most importantly, you don't have to code along. We have a lot of material we want to cover. We've sort of done bits and pieces of this, Rami and I, before, and we're covering like a very large variety of topics, and it's very information dense. So it's very important that absorb the fundamentals, the framework, the design patterns. That's important. All the code base that we'll show you today, any and all, are in the GitHub repo. We've tried to make them fully reproducible. There are going to be nuances here, especially that we found between the operating systems, especially Windows. And then there's some things that don't work on the Apple M1 yet, like RStudio. So that's why, if you get stuck or something, don't worry about it. Just follow along, and you can practice down, after the workshop is done. And we'll stay engaged even after the workshop through our GitHub and issues. All right, I think that was my last one. I think Rami, it's over to you.
Yeah, I will put the link of the GitHub on the chat. Just to quickly go over the GitHub, maybe Raul, you want just to give a overview of what we have here?
Sure. So you'll see that you'll have access to this. It's a public repo. You can clone it. The 0.0 initial setup is some very quick instructions on how to get Docker set up and running on your operating system. And then the 0.1 through 0.6 are essentially is going to follow the theme of this presentation. So you can follow along there. I'll say we are front loaded with more like keynote and presentation content. So the first few folders will be a little bit sparse and empty because we'll be voicing over. And the last few folders like Docker for R and some of the intermediate concepts, they are much more code heavy. And so we'll be sharing our screen, either have some terminal or VS Code or something open, and kind of interactively go through that.
And one of the things that we will try to keep the time, we have ambitious agenda in order to get most of it or all of it, hopefully. We will police for each other the time. So while I'm presenting, Raul will give me heads up about the time that we will be not get lost, spend too much time on something. Obviously, we will leave some time at the end of each section for Q&A. And if there is anything that we didn't answer, can always go in after the session and open issue. We'll be happy to answer about any other question. So with that, go back to the presentation and start. So we don't expect you to have Docker on desktop. One of the things that we learn on the weekend, we both use Mac and we try to install it in Windows, and it seems that in some cases it's straightforward, in other cases it's not straightforward. So if you have it, great. If you don't have it, you can try now to install it, but if it's taking too much time, we don't want to spend it. We assume that you don't have it. Anything that we are going to talk about here, the code will be available and reproducible, and you can do it after the workshop and try to reproduce it. But essentially, to go to install Docker, you need Docker Desktop. That's what we're going to use today. You have to go to get Docker, and this is the address, docs.docker.com/get Docker. So I can share. Raul, can you share it on the chat?
Yeah, I'll put it in there.
And essentially, you will have 3 options. Docker Desktop supported to Mac, Windows, and Linux. Docker is based on Linux, so on Linux is when you install it, it's just straightforward. Mac is based on Linux OS, so there is some virtualization on top of it, but it's easy to install it on Mac. The only caveat that in the new Apple chip, so there is a different installation for the M1. If you have Intel, you just need to follow the instruction from the Intel. The only difference it will make is that our Studio server on Docker does not support M1. And we were going to cover the alternative, but just this is something to wear for folks that have M1. For Windows users, and I believe that's the majority of people here, it's a little bit more tricky. So there is some restriction about what type of versions of Windows it's supported. It must be 64-bit, and I believe that today most of the Windows OS are 64 bits and support 10 and 11.
Rami, sorry to interrupt. There's a comment. Can you zoom in on your
screen?
Yeah. The font's like really tiny.
But to install, so the thing is that Windows command line is not based on Linux, so you need to install it's a type of virtual environment based on Linux, which is the WSL2, and the process might take some time, so that's why we don't want you to bother now to do it. I tried it on the weekend. It could be straightforward. If you have a specific machine, it might be more challenging with other type of machines. So that's something that we prefer not to spend time on the installation because we are limited with the time. The other thing that, so if you have a Docker and you install, if you want to test that your Docker is working properly, Raul put on the installation instruction on the GitHub, some command. You can also run the well-say Docker. The Docker image is one of the most common Dockers, the hello world of the Docker. So the command from the command line is docker pull docker / well-say, and you will see something like this. You are pulling the Docker, so that's kind of like it downloading it. And then if you run docker well-say cow say and type any text, in this case hello our users, you will get this output and I will say hello our users. So this is a fun way to test that Docker is working on your end. And even if it's not working, don't bother. Again, I think it's more important to understand some of the concept, and then you can, after the session, you can go and try to run it on your end. The last thing I want to cover is Docker Desktop. So Docker Desktop is what install on top of the Docker engine, and it's enable you to create and manage images and containers. We won't use it. You can do a lot of stuff there, but we won't use it today. All the things that we're going to do is through the command line. But the most important stuff is on the performance, to go and to be aware about the resources. This is essentially you're running a Linux virtual machine on your own machine, and you need to allocate resources. So the number of CPUs, the memory, how much swap memory, and how much disk image you're going to allocate. So it's a OS that runs within your OS. So it's important just to be aware that if you are over allocate, your machine will be slow. So it's something to take into account, how you allocate your resources. I would recommend for today, if you're running it on the side, keep it low. Nothing that we're going to use today is heavy. So I would one CPU and maybe 2 or 4 gigabytes of memory is sufficient. I think that the most common error that you get when you're building Dockers is when your disk allocation is full and then Docker cannot write. So also be aware about how much you are allocating, and when you get error about doing the build, usually the first thing you need to check that your disk image, that you have enough space. Last but not least, Docker Hub. So Docker Hub is, I would say, it's the GitHub of the images. So it's the most common platform to store images. So whenever you create image, you can go and push it to the Docker Hub. And maybe I'm talking about images in containers. Maybe it's not clear at this point. We will talk about later. But one thing to be aware that it's completely open, unless you have some kind of enterprise version, and you can restrict the access. So any Docker that you create and push to Docker Hub, everybody will have access. And I will spend one more minute just to go to Docker Hub. Let's see. So this is my account.
Zoom in a bit.
Yes. Yeah. Thanks. And when I log in, I can see the Dockers that I pushed. So we have information, but it's more interesting to see the public Dockers, and you can see, for example, Postgres Docker, which enable you to run Postgres on Docker. There is more than 1 billion downloads. That's a lot. And another popular Docker is Ubuntu. I think most of the Dockers that we're going to use today are based on Ubuntu. And when you go, you can see that there are multiple versions. And the versions typically you can see by the tagging. So within this, and this is the reason that we ask what type of CPU do you have, because you can see that there are versions for ARM, AMD 64, and so on. And then there are different versions of Ubuntu. So you can go in the description and see, like, if you have a specific one that you want to use. I typically use Bionic because it's I got stuck on this and it's working, but maybe I should move to the most, not the most recent, but there are newer version since then. But it doesn't, like, if it serves you, just you can stick with one and run with this. And you can see you have information about the CPU that it's supported. So that's kind of like, you need to be aware of what machine you are using. Typically on Intel, it's run well. If you have unique devices like Raspberry Pi, which is, I believe it's ARM 32, now they have ARM 64, but that would be like something you need to be aware. Otherwise, it should be straightforward. We will go back to Docker Hub later on. So with that, we can start to talk about Docker. So I would say it's not the future, it's already now. Docker is a very, it's a industry standard for many fields, not necessarily only data science. It could be engineering, mainly software development, and it enables you to develop code with reproducibility and to put stuff in production in a seamless way. So I always say that for folks that I meet, data scientists, mainly new data scientists, that it's nice to know some fancy deep learning models and all those things, but if you know how to deploy linear regression with Docker, you are God. Because I think that today it's more important than depending on the context, but it's very important to be able to put your code in production. And again, Docker with R, it's amazing. That's something I discovered while I started to develop some of the packages for supporting the COVID-19 data. And this is the time that GitHub Actions came. And together, this combination of this specific example of GitHub Action, GitHub Pages, R Markdown, Flex Dashboard, you can do a ton of stuff, fun stuff, and also useful stuff. And Docker just provide you environment and framework to create those things and deploy them in a seamless way. So here is a short list of what you can do with Docker in the context of R. You can build data pipelines, CI/CD tools, deploy Shiny and Flex dashboards, data automation, R package automation, modeling, and reproducibility. And this is some example, again, going back to the coronavirus package. So this package run a daily data refresh that goes into John Hopkins repo and pull the data. So I deployed R Markdown that refreshed data script that refreshed the data, and it's running on GitHub Action. So you can see on the right side on GitHub Action, the data pipeline running. And I tried at the beginning some other alternative that you can go get a virtual machine and install the packages. I had a lot of errors, and that's what drove me to move to Docker. And since then, it's really working seamlessly. It's really reduced a lot of the issues that I had before. The other thing that is, as a package developer, is super important is to automate our CMD check. So anytime that I'm pushing my code, it's running on GitHub Action, our CMD check, and it check if the code ran properly, and if there is any, if it's failed, so you get on the tag and an email saying that there was some failure. This is the fun stuff. So in this example, I created a COVID-19 tracker for Italy, and this dashboard is get refreshed on a daily basis, refresh the data, render the R Markdown all within Docker using GitHub Action. You can also do machine learning stuff. This is example of another Flex dashboard that generating a forecast and update data on an hourly basis for this is forecast for the US electricity. Last but not least, Postgres and R. I think most of the folks that are using R and database love to use Postgres. There is a great integration. So one of the workflow that when you work with databases is like you are building, you are taking two Dockers, one with R, the other one with Postgres, and you connect them together, and you can easily create a code base to populate data, build pipelines, and so on. So, the bottom line, this is enable you to have seamless reproducibility and production. So before we will go into more details about Docker, let's talk about what is reproducibility. So I remember when I was a research assistant while I was a student in university, I've been told that set seed is the reproducibility. But then you get to the industry, you realize that there are more stuff like version control. You want to make sure that all the people are using the exact same code and you are tracking it. And then the package version or the ID that you're using will determine or affect your results. Obviously, also the R version that you're using in the context of R, and the OS type and version. That's something that you learned, and there are a lot of issues that you can see that because each OS might use a different compilers from the C or Fortran compilers, and the versioning might change, and that might affect your results in extreme cases. Last but not least is the type of hardware that could affect your reproducibility. You may get different results because the architect is just different on each CPU or any or other components of the hardware. So Docker in the context cover you on all beside the hardware. It enables you to set environment. Obviously the version control you need to maintain, but if you have the same version control, then it's enable you to set environment, one environment, and you can share it with others. I believe that most of the R users don't really get affected from hardware. I think it's more like something that software developer, the folks that are developing apps that are running on real time, this is where hardware is important. So we can, for now, ignore the hardware. So this is an example of where Docker can be used. And in this case, this is the reproducibility problem. And really, I took it from my time as a research assistant, working in a lab, collaborating with different students, and you're creating some code, you're working for some professor. And let's assume that all of us are using R, we're using version control, and we're running some code. We set the seed, and student one get results for some code that ran, and it's 5.297. Student to get something similar, it's a 5.298. Maybe it's a rounding error, and student 3 get 5.3, and the professor get error. And when you're going and check what they are running on the backend, so you see that each one might have different version of R and different packages of R, in this case, the dplyr and tidyr, and each one has a different OS. And that's caused some issues because of the version. You may have functions that change from release to release. Some deprecated and not exist anymore. So that's something that really can cause you headache, and when you are trying to run the same code, and that's one of the reasons that running the same code may get different results when it's running on the different machines, different versions of OS, and so on. And this is where Docker can help you and to create a full reproducibility. So in this case, if you are creating an environment of Docker, you set the version of R to 3.62. You're running dplyr and tidyr version 1, and you most likely all of the users will get the same results. And this is, if you go to Stack Overflow, you will get all of those people that open issues that are related to reproducibility and in production, where you're developing on your local machine, and when you are trying to deploy it in some AWS or RCD Connect or anything, in this case for Shiny, you're not getting the same results in your local machine. And this is where most of the cases it's just you have your own environment, and it's a package collision. It's also could be that the OS, like you are developing on Mac or Windows and you deploy it on a Linux-based machine, and there is something missing. Where Docker can help you, because you're setting, if you are deploying with Docker, you are developing with the same type of OS that you are deploying, with the same type of versions, and everything should be one-to-one. And this is like example from personal pain that I had. Someone sent me a Shiny app that the Shiny app renders some of the plot to run faster. So some of the there was a caching layer that rendered the pre-loaded and rendered some of the plots, and I couldn't load it on my machine. And when we dig in, after a while, we realized that when you render, I think it was in this case Plotly, it's using cross talk package, and it's setting the path by the version of R that you are using. So the person that created the app, he had version 3.5, I had version 3.6, and it's now sounds like very trivial, but it took us a while to understand why it's not working, and it was, this could be avoided with Docker. And essentially, again, developing on Docker is like I'm taking this Linux machine, I'm putting my code, running it, and hand off to the folks that are working with me. It enables you to reproduce, like if I'm getting some error, you will get the same error. So if you are working in Teams, it's the perfect setting for environment that enable you to debug and deploy your code with a minimum friction with the OS and hardware. So the key takeout is working with Docker could really save you a lot of unnecessary pain and grief, and this is from personal experience, and I believe that Raul can claim the same. So now we can talk about what is Docker. I know that I throw a lot of terms, images, containers. It might sound a lot, but let's now go and dive and discuss what is Docker. So Docker is a platform for OS virtualization. So I would say it's similar to virtual machine, but it's not the same. From computer science, it's a different thing. So in virtual machine, you will deploy your OS on top of a machine, and here you are deploying OS on top of your OS. So you will deploy run Linux within your machine. And there are some advantages and disadvantages, which I'm not going to get into, but there are more advantages with respect of virtual machine. It enables you to use isolated containers, so it's easy. Like the reason that people are using the term container, so you think about like in a port, the ship bringing containers, and you are using a crane to take them and put them in another place. So that's kind of like you can take a container out and put a different container and it will fit. Enable you to package different components of the software. So for example, if you have a project that you need a specific components of R, like you're using a specific dplyr version and ggplot or plotly or any version of Shiny, it enables you to set the versions, and once you set it, it's there. Enable, we already talked about it, like enable seamless shipment and deployment. Like once you start to work, an example is like GitHub Action. If you are using GitHub Action to deploy code, it's amazing how much easier than the alternative of running on real time whenever the machine is running. There are free and enterprise versions available. Recently, Docker changed the policy. So if you are, they have it on the website. If you are a big organization, this is where you need to pay for the license. But otherwise, for personal users or for small organization, it's still free. So this is an example of how Docker is built. So you have your infrastructure. It could be your own machine or some server. On top of it, you will have your operating system. So in this example, I have iMac. On top of it, I have Mac OS. And then I have Docker engine running on top of it, this is create the virtual Linux environment. And then you can start to deploy apps. So you can essentially, this is where, if you're familiar with Kubernetes, you can manage multiple apps, each one running on containers. And if one app crash, you can easily go and redeploy the Docker. And in the world of DevOps, I think that was a game changer, saving a lot of time in debugging when you're taking code from the developer into the production environment. So what is the workflow? So typically you will start with some project, and to create a Docker, you will need to create a Docker file. Docker file is a list of instruction for the Docker engine of what you want to bake inside your image. So then you will run a build command and you create an image. And this image can be launched inside a container in some server, and then you can start to develop. So typically on any project that I'm working, the first thing I'm doing is create a Docker file, understand what my requirements, build the image, and then set container work in a virtual environment. And that's the environment that I will use also to deploy my code. And you can use it for deploy Shiny apps, to develop on VS Code and RStudio. VS Code is I believe that most folks are not using VS Code in the context of R, but for folks that are using M1, that's the RStudio Server doesn't support yet the M1, so you should use the VS Code. One thing that I can say that I and Raul, we moved deeply to VS Code after we started to use VS Code, especially when you're developing in multiple languages like R, Python, and Bash. It's very convenient. So that's a good idea to use in the context of R. And at the end, we're going to show both ways. If you want to run it inside our server or inside the VS Code. So let's dive into the Docker file.
Rami,
yes.
We are running ahead of time, like 10 minutes. We had a Q&A for 10 minutes and a break before Dockerfile, but we're doing good on time. Before you move into the Dockerfile section, if folks have any questions, either put them in the chat of stuff that we've covered so far, or if you can unmute yourself and you want to speak up, that's fine too. I don't think we've locked anything down, to be honest.
Yeah, so maybe we can do the Dockerfile and then we can pause for a question and take a break.
Okay.
And folks, feel free to ask questions on the chat, and Raul will try to answer them, and then we will do a full stop before the next section and for Q&A. So Dockerfile contain list of it's a manifest. It's of what you want to build, and there are basic or the core commands that are used in Dockerfile. I'm going to cover it now by this example. Let's assume that you want to deploy to run R code that doing the following. It's print two environment variables, message1 and message2. Very simple code. It's pulling with the sys get env from your environment those variables and print it out. So you will create the following Docker file, and Docker file always start with a from command, and the from is just telling Docker where you need to take the image to start with. Always you need to start with some image. You can start at the level of the OS, let's say some flavor of Linux, such as Ubuntu, but you can also take other images that someone already built on top of Ubuntu. In this case, we are taking our version 4.2 that Rocker created, and we're going to speak later on about Rocker. So that's kind of like, I don't need to worry about installing the R and the packages that I need for this exercise. So it's coming with a bunch of packages and with the R version 4.2. And again, like the place that you will want to go and check images, available images is on Docker Hub. Rocker is the main hub for R images. They are providing a variety of images for R from different versions, and R server and Shiny containers with support for Shiny. Then the next step is, in this case, not necessarily this is the order, but like we're typically, after you are defining the image, you can set your labels, and labels are used to add some information to about the image on the image metadata. So in this case, I'm defining 4 labels: the maintainer, some info description of what this container image is doing, where the code is, and the license. One thing to notice that if you, after you build and run Docker inspect, and you can get the metadata, that first you can see that the 4 labels are here, but also you can see that Docker inherited the previous labels from the Docker the image that you imported. So in this case, I can see that the Docker image labels are also there. The next is defining argument and environment variables. So those are the same but different. So argument define variables that can pass to the image during the build time. So once the next step after you create the Docker file is to build it and create the image. And after you create the image, you can run it. So I might use this term build time was referring to building the image, and runtime is when you deploy it inside the container. Argument are useful tools if you want to define variables and that you can change it during the build time. So in this case, I'm defining message 1, which is the first environment variable with argument. And that's just saying if I didn't provide any argument during the build time, use this as default. The second variable is I'm defining as environment variable. And this is the second message. And as you remember, this is our script. And during the build time, you will see that this is the output as expected. Now, one thing that you can, the difference between argument and environment that you can customize during the build time. So here I'm using the build arg to define a different message. And as you can see that I changed the message from welcome to the user 2022 conference to we love R. And think about it like when you have a script and you want to be able to customize it. I think in my end, I'm typically have a Docker that I'm installing from scratch the R, and I have argument to define the version. So I can, if I want to change the version, I just set it as argument and rebuild it. One more thing to know about the difference between environment and argument, that the environment is saved after the build time, so it's available during the runtime, where the argument is only available during the build time. And as you can see, again, going and inspecting the Docker and get the metadata, my message is here. And also you can see that like the labels I'm inheriting from the previous, from the Docker that I'm importing, its previous environment variable. Next is the run command, which enables you to execute commands from the command lines inside the Docker. And that's probably the most common command that you will use. So in this case, I'm making a dir inside the Docker to copy my script, and often you want to install, and we were going to cover next on the following sections about how to use run. But essentially, it's very useful command, and it just enables you to run stuff from the command line within the Docker. Last but not least is the copy, which is, as you can see, I want to copy, which enable you to copy from your local machine files into the Docker itself. In this case, I'm copying from my local machine any R files into the Docker script folder. So those are the main commands, but there are other commands that are very common. I will go briefly. We're going to see them in the demo. Expose defines the port that the container is going to listen during the runtime. It will be useful, or this is where you're going to use it when you are running Shiny application, Plumber API, or our server. You want to expose it, and then you can log it from your browser with using some of the port on your local machine. CMD enable you to extract commands during the runtime. So unlike the build, unlike the run during the build, which is just available during the build time. CMD is enable you to run commands that when you're running the container itself. Entry point enable you, it's similar to CMD, enable you to execute commands during the runtime, but it's also enable you to add some arguments. Volume is enable you to set to mount a point inside the image to expose it, and that's enable you to mount it with your local folder. So imagine the scenario that you are running a Docker on your local machine and you want to load the folder from your local machine. That's the use case of volume. Workdir is defining the working dir inside the image, and that's kind of when you are using some of the commands, it will use it as the default. I can maybe pause here and go to the reference, and all of those commands are available here. There are more commands, but the one that I showed are the most common commands that typically we are using. But there are more that I didn't cover, and anything there is a good details about how to use those and when to use. So the last topic before we'll go to the break is the image layers. So we talked about building. When you build, you're creating an image. And the way that it's architected is that Docker create for each step a layer. And the reason is that is for efficiency. Once you build the image and you don't want to rebuild each time that you're running if you already cached it, so it enables you to cache the layers and save some time during the build time. And it's also available to when you are using other images. So again, let's go back to the Docker file that I showed before. And this will create 9 layers. And you can see that when you're triggering, there are some layers that are related to the internal load of the Docker, the initiate of the Docker. And then there are layers that related to, here is the case that we are for importing the Rocker file or the Rocker image. And then there is for each step, there is the corresponding layer. And again, you can see those layers on the metadata. Docker provides some serial number for each layer, so you can go and track it, and you can draw an advanced scenario. You can say, I want Docker during the build just to rebuild from layer 5 and keep the rest as is. So let's imagine the following scenario. You want to create a Docker with the following requirements. Our version 4, you want to install tidyverse packages, have Shiny and RStudio Server. So there are a couple of approaches to create this Docker. The approach one is a multi-steps approach that you are, in this case, using 3 images. You first install the base R, and then you export it to the next one and build on top of it a Shiny server and tidyverse, and continue and add on the third image on top of the previous one, RStudio Server. The other approach is like I'm creating a one Docker file that I'm building all at once in one Docker. So let's see what is different between the 2 approaches. Let's say that we are starting with building multiple steps with the first approach. So we will import some base image from Ubuntu in this case, we install the required compiler for R and then install R. And then this is the first image. We will tag it as base R4 and we move to the next image. The next image, we will take the base R4 image as the base and start to build on top of it. We'll install the tidyverse. We'll next install Shiny Server. And that's the next image. We will tag it as tidyverse 4. Similarly, we'll continue to the third image. We will start with the tidyverse 4 image as the base. Install on top of it RStudio Server. And then that's the end image that we're going to use. And you can see the relationship that each image start with the previous image using the form. So in the second image, we'll use form base R4, and the third image we'll use form tidyverse 4. The other approach would be, let's build it in one image. And you can see you will have the same steps and it's all going to be captured as layers. So how layers can be useful. So let's say that now we want to upgrade the R version. So previously we had version 4, now we want to move to version 4.02. So since we are not going to change the baseline image, the Ubuntu and the compiler, this is cache layer. So it will just pull those cache layer and put it inside the new Docker. Then we're installing a new layer. And from this point, since we changed the layer, the following layers, even if we're not changing anything, we'll have to reinstall again from scratch. So this is something to think about when you are building Docker. If you have, mainly during the development, if you have multiple layers that you think they're going to be changed quite often, try to put them as last, that you don't need to rebuild the Docker each time from scratch. Once you start to work with Docker, you will notice that the build time could take some time, especially when you don't have the cache of the layers. Once you cache it, it could be faster. So we saw two approaches. The approach one, it's convenience during development as you keep changing, and typically I will install the best R and something that I won't change, but the last layer is something that I keep changing, so I don't need to install the R each time that I'm changing stuff on let's say I need a new packages. Order of the layers, as I mentioned, do matter. It enables you, if you are organized in an optimal way, it enables you to run faster during the build time. The downside of it, that image size might be bigger if you are using multiple images. The advantage of approach 2, it's enable better optimization of the image size, but the runtime might be longer. So this is something typically what I would do. I will use approach time during the development, and then on the production, once I figure out the Docker is on stable mode, I can go and rerun everything in one batch. So how do we have time? I think we said like 3 o'clock we will stop, so I will stop over here.
Yeah, Rami, we are well within time. There's some open questions I see in the chat window and some in the Q&A. So let's start with those. Before we do, just some administrative stuff. Rami, Susanna is asking, can you put up that last slide again? So till I talk about this, if you can share that last slide that you had.
Is it this one?
I believe so. Susanna, if you could say yes or no in the chat. Till then, there's someone asking, and it's a very good question. I wasn't able to do it either. Is how do you full screen this when you're looking at a presenter? And I contacted the organizers. it doesn't seem that we can full screen. The only thing you can do is if the left-hand side blue bar is expanded and you take your mouse and just go up to the top left, you'll see a little like less than sign. You can click on that to like contract it. It'll still be there, but you can contract it. And the same thing with the chat window. You can sort of just like contract those ones, but there is no like expand into full screen. So Rami and I will keep aware of that and manage our font sizes because it's going to reduce your usable screen space. Throughout the rest of it, if you guys can't see anything, please let us know in the chat that it's still too small and we'll expand it.
I'm trying to figure out how I can stop to share. It's
Okay,
disappeared,
yeah.
option.
Till you do that, let me go through some Q&A. So let's see, bottom to top, let me see. So Taryn was asking, does the Docker replace other environment tools like RN, or do you use them together? Taryn, that's a great question. We do use them together. They don't, Docker doesn't, TLDR, short answer, Docker doesn't completely replace it. The reason I won't delve into it is there's an entire section where we're going to go into RN and actually look at some code and example cases. So I think it'll, you should get your answer then. If not, then let's talk about it again. Sophie was asking, I have an OS system and I want to build an R package and send it to someone with Linux. Can I build my package via Docker so that it is Linux compatible? So Sophie, I'm guessing that you're working on a non-Linux operating system. You want to build something, send it to someone for Linux, and I think that's a perfect use case for something like this. You could set up your Docker, in fact, exactly on even the Linux distribution that your colleague uses, and set up a base image, install R, install the dependencies, and set up the environment to even replicate what your colleague has, and then develop your package in this Docker container built on this image. And then if it works in your Docker, there's a high likelihood it will still work in their system. Again, I say high likelihood because you're building a very controlled environment in Docker, which is great because you're replicating the Linux bit of it. But there could be other dependencies that the other person may not have in terms of libraries in their operating system. So it's a better approach, but it doesn't guarantee that it'll work unless you provide some instructions on particular dependencies or environmental variables set up that your package needs.
If both of you are
Does that
using
answer your
Docker,
question?
that's the simple way. So it doesn't matter the OS, because this is what Docker kind of like helping you to have a same environment.
We have another question from Simona. So if she says, if the Docker file does not change, but the R script changes, how can one enforce the rebuilding of the image starting from a specific part of the Docker file? So, Rami, you want to take this?
Yeah, I think that by default, Docker identify where you change. If Docker identify a change, it will continue and install from that point everything, and it won't use the cached layers. So that's really depending how you define your Docker. One thing that I showed in the previous example, that I'm importing the Docker image, and after the first time it will cache it, but then I'm running a command make dir, and this is something that you cannot cache it, because anytime you are writing inside a Docker, you kind of like resetting the layers, and from that point it will rebuild from scratch and won't use the layers. There are advanced options that you can say to the Docker, don't cache. I think it's like we saw it today. It's like dash no cache. So then it won't never cache. But I think also you can say start from a specific layer. It's something we need to dig to it, and we can find out. If you want to open a issue after the session, and we can follow up on this.
All right. Francisco is asking, what is the difference between layers and containers? So, Rami, you want me to take this?
Yeah, go ahead.
So think of containers as, okay, so we have a Docker file that specifies how you want to build your image, right? So the Docker file builds the image. Now, if you're familiar with like object-oriented programming, maybe this analogy helps. Is you're building a class, right? The image is the class, and then you instantiate an example of the class, and that's the container. That's one analogy. If you don't do that kind of programming, then what's another analogy? So the image is, here's everything that's within. So the image has all the layers within, right? So here on screen, you see RStudio 4 is the name of the image, and it has all of these layers within the image, right? So you start with Ubuntu. So Ubuntu, that layer itself is going to have a whole bunch of other layers and how they built Ubuntu, right? Then you add R, you add Tidyverse, you add Shiny, etc. So you have all these sort of layers within, and that's the definition of the image, and you build it, and that's your image. Container is you're saying, hey, take this image and run it and create now a runtime version of this image so that I can start like interacting with it, I can code in it, or like, so it's actually live. So the image is in a sense not live. The image is like a definition that's compiled, that resides on your computer. When you run it, that's when you're launching a container that's now live, that's consuming memory and CPU, and you're interacting with it, right? So, and you can have many containers. So you can have the same image and you can launch 5 containers of the same image, right? So the layers are sort of the definition within the image. Once you start and run an image, you have a container. I hope that helps.
So essentially here the white frame is the image, and inside it, the image you have multiple layers, and once you deploy it and it's consuming, as Or mentioned, the CPUs, the terms change to container. Or maybe we stop for 5 minutes break for let folks to.
Okay, let's do that. 5 or 10 minutes do you want to do?
Let's do 5, and then the next on 4 we'll do 10 minutes.
Okay, I see more questions. Don't worry, we'll get to them. One question is, will the slides be available later on? Yes, we can definitely put these, we can put a PDF and put it back in the GitHub repository. So let's take 5 minutes. It's 3:10 PDT. We can come back in 5 minutes, 3:15. So
yeah, we can stay here for questions if there are any questions we didn't answer, so we can. Oh, I answered some of the questions on the chat. I think I left 3 questions that I think it's worth everybody to
Gotcha.
to answer. Yeah.
All right. That's 5 minutes, folks. So let's get started again. I hope that was a decent bio break. Got some tea or coffee. We'll spend another few minutes going through some questions and then move on to the next section. Okay, so I see 3 questions. Are those the ones, Rami, you're referring to?
Yes.
Okay. I'll take Suzanne's question on the limitations of Docker because I just made some notes. I was thinking about that over the break. So her question is, can you delineate the limitations of using Docker? And I think that's a good question. So I'm going to pull from my own personal experience of adopting Docker, and Rami, feel free to add. But I can think of like 4 or 5 things that are challenging to adopting Docker, right? The first is really a learning curve. And it's because you have to now learn not only Docker and Docker technology, right? So it's all the stuff here, but you have to also alter your workflow. And so if you're used to using, say, RStudio, and you're used to just, installing packages as you need them, have access to all the folders on your machine as you need them. That completely changes when you move to Docker. So you have to plan ahead. So there is that learning curve. And then it's not only you, but if you're part of a team and there are 4 or 5 other data scientists or data engineers who don't use Docker, it's hard if you're the only one. So there is that adoption curve, right? And education aspect that's I'd not say that's a limitation of Docker, but that's just one of the pain points of adopting Docker. And we've gone through that in our team, right? I think the second one is maybe like Docker Hub or a place to host your images. If you're doing open source work and all, you can use Docker Hub, no problem. But if you're doing proprietary work, then you can't. You need an enterprise sort of like hosting area, right? So you may have to pay for that. You need licensing, some of that kind of stuff. Secrets management is another one, right? You don't want to embed your secrets within the Docker image, especially if it's public. So how do you handle that? How do you pass things back and forth? And the last one I can think of is if you use RStudio Connect to deploy your Shiny apps or your dashboards, RStudio Connect can't natively use Docker. So if you package your ETL pipeline or your Shiny app within a Docker, today RStudio Connect cannot say, oh, I'll just launch that Docker, I'll create a container and then host it within RStudio Connect. It cannot do that. So if you are an RStudio Connect user, then that's a challenge. You have to sort of alter your workflow. These are kind of the things I can think of off the bat. Rami, anything else?
Yeah, the learning curve. How do I say it? It's worth it. The other thing is it's related probably to the learning curve is that your workflow, you need to adapt a different workflow. Like there is some cost of installing, like installing packages. This is where it's not always as smooth as it will be on your machine. Sometimes you really need to go and install your missing compilers, and you need to figure out and debug it. So, but the bottom line is worth the time that you spend on it, especially if you're working in a team. The amount of time you save up on debugging and when you deploy it to production is worth any second of learning this tool.
Do you want to do one more question and then we'll start the next section and then come back to Q&A?
Yeah, so there is a So Fania, I hope I pronounced the name correctly. I apologize if not. What is the easiest way to access my own R package from within a Shiny container? So so if I understand correctly, you want to install your own package on top of to be available on the Docker. So you can do like import the Shiny server image from Rocker, and then create your own Docker file that you build on top of it your own package and install your own packages. I hope this has answered your question. So while we 3:20, I suggest we will continue to the next section. I will try to answer the questions, and we will have more stops for Q&A.
Okay. So I'll share my screen now. Let me know if you can see it.
Yeah. Yeah, on full screen. I think all you're on mute. And I think we lost Raul.
I'll tell if you're able to see my screen or not.
We lost you for a second. Can you reshare?
So I think I'm still sharing my screen. Are you able to see this?
No.
I'm gonna
Why don't
push
you
it
leave
this
the
way.
session and come back?
Okay, I'll stop presenting and then share again. Can you see my screen now?
Yeah.
Okay, so let me just keep it like this. Maybe when I went full screen with this, it errored out. So we're going to talk about Docker command line interface, right? So there's a bunch of these commands that are very useful, and we're going to spend just 2 minutes on this slide, and then I'm going to switch over to VS Code, and let's actually look at a few commands and go through them, right? So Rami had spoken about this, but we have a Docker file and perhaps some project files. And the first thing that we want to do is build a Docker image, right? So there's a Docker build command that we look at, and you can tell it, what files you want. You can give it a tag to, what you want to call the Docker image, and we look at that. So now you have this image, and you have many images. So you have things like Docker image ls to say, show me the images I have, Docker image inspect to say, for this particular image, I want to peek into it and I want to know more about it, right? So this is all the images. Now you can take an image and launch a container using Docker run. So it has some arguments and you can say which image you want to run. And now you have an active container. And then there's a whole bunch of commands to interact with the active container, to do stuff with it, to investigate or ask questions about it and get your work done, right? So that's sort of a high level. I want to set the stage for where we are going. So I'm going to switch over to VS Code. And again, a lot of this, and I'm going to, Rami, keep an eye and tell me if the font, like folks, let me know if the font's still too small. So I'm going to be in the Docker-CLI 03. You don't have to follow along on your end. It's all, again, completely reproducible. So I'm going to just like voice over a lot of this, and let's go through it. Font size okay? Can folks see this?
I think it's okay, but if you can a little bit increase it by a little bit.
Sure.
Yeah.
Is this better?
That's fine. Yeah, I think it's fine.
All right. Okay. So we are right now in VS Code, and I've opened up this Docker CLI. So I'm going to sort of show you a lot of the commands that we want now. So let's start with Docker build. So Docker build essentially builds an image from a Docker file. And there's a bunch of useful arguments. So the first thing you have to know about Docker build is you have to be in the directory, well, by default. So let's, I'm going to simplify things. So by default, for the most part, you want to be in the directory where your Docker file exists. So I'll open the Docker file, right? Here's a Docker file that we're going to build. So let's look at it. So it says from Rocker Arver 420. So this is essentially an image that has R, and you can guess that is version 4.2.0, right? That's all it is. Putting some labels, maintainer info, the two messages as arguments environment. This is essentially the script that Rami was talking about before. Okay. You're going to run within the image a make directory and make a directory called scripts. So it'll do that within the image. And then you're going to copy everything that's .r into that directory. So essentially you're copying this one hello user.r file, right? And then the last command is you're going to run our script /hello user.r, right? So that's a Docker file. So now we have a Docker file and we want to build it into an image. So that's why let's start looking at some of these commands. So since I'm here, we can run essentially Docker build, and dot means run stuff in the contents of this directory. So if you run that, you're going to see something like this. And for now, let me just expand this. So we are in that directory, and you'll see that it's okay, I'm loading the definition from Docker file. By default, it'll always search for Docker file. Okay. And then it starts running each of the layers. So layer 1 of 4, so there are going to be 4 layers. It's a from Rocker Arver 420. The reason it was docker.io is this image is pulled from Docker Hub, and then it's docker.io Rocker Arver 420, right? And then it's running the make dir scripts, it's copying the scripts, and then run our script is the final layer. The reason it says cached here is because I've run this before, and so this image already, like all these layers already exist on my machine. If not, it would not say cached, right? They're saying exporting to image, exporting the layers, and then writing the image. Now here, because we did not give it a name, it's going to assign this alphanumeric value by default, okay? And so the next command we want to look at is docker image ls, which is just list all the images. And on my machine, you see a whole bunch of them. Okay, so got some feedback, but I'm assuming that is gone now, right? And if you say all, then you should see even the image that we created. Let me show you that. Now, one thing that we don't do is do it like that. We always give it a tag. So you can build it with the -- tag or a -t, and you give it a name. And the way these names work is usually you can call it a namespace or like a folder almost name, right? / an image name, colon, a tag name. So something like Docker for R v1.0, you're only doing sort of this portion of the schema. Or you could have something more complicated, like your own organization could have an internal Docker hub, right? So that .com / your project name / maybe the name of the image could be something like Shiny app. And then after the colon, you can have a tag that's more relevant. So something like prod version 2.4, dev version 1.2.2, what have you, right? And these names, they can have dashes, they can have dots, they can have underscores, right? So the same thing that we built, we can now write something a little better, which is -- tag docker for R maybe we can say test, right, is a tag, and then dot, right? And what you're going to do is again build it, and now it's going to actually give it a name. So now if we do Docker image ls and say we grep for Docker for R, you'll see a bunch of them, and Docker for R test is the one that we built. Okay, and you see the reason here it says 8 hours ago is again because I created this 8 hours ago. So when you have cached images, it's going to just reference that. It's saying, hey, everything is the same. I already had all these cached layers. I'm not going to rebuild this. And so all I'm going to do is now give it the name that you wanted. This is the name that I wanted, right? And you can see how big it is. This is 910 megs. This is the unique SHA value, right? And this is a human readable. Basically what you're seeing on the left here for all of these, this is the name and then a tag if you have a tag, okay? Now, you could build it using a specific Docker file. So I won't run this because the Docker file is default, but considering a case where maybe you have a couple of Docker files in your same directory and you wanted to run something like, hey, I want you to use Dockerfile _2 instead of the default Docker file, you have a -- file. And then the -t is the tag, right? Honestly, best practice so far that I've seen and that we use is we don't do this. We keep everything in separate folders. If we have multiple images, we'll have separate folders, each with a definition, each with one Docker file, and we don't have multiple Docker files. But I can imagine there might be a use case for you to see. Okay, so we saw Docker image ls, which is list all your images. There's a Docker image prune, which gets rid of unused images. So you can think of images that are pulled as part of another image, right? Say, for example, I have image A, which is pulled, and then I created an image B that's based off of image A, right? In B's Docker file, I say from A, so take A and then add like 3-4 things to it. And then down the line, I delete B. I'm like, okay, I don't need B anymore. And A is not used anywhere else. It's like this hanging image. It doesn't delete it by default. Prune is a command that you can use to like get rid of stuff from your machine. And it's not just image. So you can do Docker image prune. You can do Docker container prune. You can do Docker system prune, which just prunes everything, anything that's like hanging. You say, okay, remove all dangling images. Yes, I don't have any. So it's going to say, okay, I don't see anything. Another useful sort of paradigm is this Docker image ls and then grep, because you have, over time, a whole bunch of images. It's hard to see. So you can grep on something. So for example, these are images that I can't type today, that I use for myself. And that's a useful sort of paradigm. The last thing on the image is inspect, which is very useful. And this is used to peek into an image. And this is what Rami had used to create some of those slides that you saw before. So in inspect, what you're going to do is, I'm going to try and full screen this. You're going to get a big JSON payload. And this JSON payload has everything about the image. So it starts with the ID. So you have the full SHA value in there. Then you have the repo tags. Now notice when I ran this before in preparation for this workshop, I'd used Docker for R /simple test. But in front of you guys right now, I just use Docker for R test. Well, it's intelligent about that. It doesn't start replicating this image on your disk. It just keeps one image, which is the unique SHA, and says, hey, you have these bunch of tags that are all talking about the same thing. So it keeps that list of tags there. Other useful things are when you created it. Down here, some other useful items are variables. So what environment variables you have. For example, remember we created the message to variable, which was an environment variable. So you can see that that's in here. Labels. So we had created the code, info, license, maintainer label. So recall that these were labels that we created. So if I open the Docker file again, these are labels that we created. However, you'll see other labels that are inherited upstream. Because we started from Rocker or Ver, there were labels that were created in that image. And you'll see those labels in here as well. This structure, by the way, if you've seen this org.opencontainers.image.authors, there is a reasoning to this madness. There is an effort to standardize the labeling. And you'll see that if you Google some of this, you'll see that there's like recommended patterns of how you can put these labels so they're more programmatically accessible. And that's why it looks like this, is image.authors, image.base.name, etc. You don't have to use it. You can call it whatever. If you learn this schematic and use it, it's considered best practice. Other things that are interesting is what operating system is in the Docker image, and let's see what else. Layers. So here's all the SHAs for the layers that are in the image, and the last stack type, right? So Docker image inspect is a pretty useful command to peek into images that you have. I'll pause here for a moment. Any open questions on this so far? All right. I'll take silence as a no. And now let's move to run. So
on the chat.
Okay. So remember, right now we did the build. So we took our Docker file, we took some project files, we did a build, and now you have an image. We looked at all the images that we have, and we ran a Docker image inspect to peek into a particular image, right? So now we have a static image that resides on our machine, and let's run it and do something with it. So that's the Docker run command, as you can imagine. Okay, so the simplest one is Docker run, and then the name of the image with the tag, followed by what command do you want to run inside the image. So this is one way of doing it. So what this is going to do is it's going to say, hey, start this image, and then I want to run a command in it, right? So it's going to go to shell, for example, within the container, and then I would say echo hello. Okay, so this is a little anticlimactic and boring, but a lot has happened in the backend. Okay, the image has been started. There's a container that was started following all the rules that we had defined in the image, and then in the shell terminal in that container, we echoed hello and we stopped it. Okay, so all of that has happened, and then we see hello. Okay, maybe a little more exciting command would be to say Docker run, and there's these arguments that are useful, --rm--it. So what this is saying is --rm is I wanted to run a one-off container. So once I'm done with everything, just delete the container. Don't cache it for me. I don't care about it. Okay, so that's the RM. -it is interactive mode. So I want you to start an image. I want it interactive. Here's the name of the image, and start bash in it. So start a terminal, and don't quit on me. I want to do stuff within it. So if we run this command and run it here, what we're doing is, again, it's the same image as before, but now we have a bash terminal. So now you're in a running container of that image. And now this is a Linux machine. So you can do everything that you expect from a Linux machine, right? You can ls into it. You can check out what's in Rocker scripts. You can move to home and see what's in there. It's empty. We can go up, and I think the scripts directory was the one that we created. And we have the hello user.r, right? You can, print it out. Everything that you typically do, you can do, right? Now, this is, if you're used to virtual machines, this is essentially a standalone container, right, running, and you're peeking into it and you're running things in it, okay? If you hit exit, you exit and the container stops, and you're back to your local machine. Does that make sense? So that's the IT, very useful when you want to run interactive ones. There's another useful argument called -d, which runs a container in the background. So it allows you to get back your terminal. So what happened in this one was your terminal was engaged until you X out of it. But say you want to run an image that's running in the backend. So you just want to fire it up. So I'm moving to a different image, Rocker RStudio, because it actually serves up RStudio as a server. So I know that it's going to keep running. So if I run this, what's happening is a container has been launched in the backend. The name of the container is this unique SHA value, and I've got my terminal back. Now here's a place where it's useful to introduce the next command is docker ps is show me active running containers. So if you do that, you'll see it. You'll see that it's given you the SHA value, which matches this first characters here. Here's the name of the image. We created it 21 seconds ago, right? And it has an open port 8787, which is for RStudio. And we'll look at that a little downstream, right? And by default, you're going to see this names column. And it's going to give it some very creative and colorful names just to be user friendly. Okay. And so if this image is now currently running, if you had code that's actually doing some processing, or if this is serving a service to some external users and they are touching it, maybe it's a Shiny app, this is now going to be actively using memory and compute on this machine, right? So if you want to stop it, there's a couple of ways. You could do docker stop and give it the container name, the container ID, which I can copy paste, or I can copy and paste the little, more human readable name. Either way, this is now going to stop the container. And now if you run docker ps, we don't have any active containers anymore. Okay. Remember, the image is still there. So docker image ls grep rocker, you'll see that all of these images, which are just snapshots of say RStudio, are on my machine. So this one, for example, I created 3 days ago. The container is the active running instance of that image, which we started and then stopped. Okay. All right. Now here's another one to add to that. So now we want to run something and we want to give it an argument, right? So -e is a way to give an argument to an image, to a container. Okay. So what is this doing? This is saying, hey, docker run -e. So I wanted to give it an argument. And the way you give it is you give it the name of the variable equals the value of the variable. --rm -it we have seen. Get rid of the container once I'm done with it. And I want you to run interactively. So open an interactive session for me. Here's the name of the image. And run the bash command once you spin up the container. So as you'd expect, we are now in our terminal. And now if we do echo new var, you'll see you have the environment variable that you've passed to it. So this is this paradigm is very useful for dynamically passing arguments to an R script, for example, right? Because in the R script, you can say sys.getEnvironment, and now you can get maybe parameter settings or what have you. When I X out, again, the container is gone. We can verify that doing docker ps, no active containers. I'm going to show you one more, and then I'll pause for any questions on stuff so far. Okay. The next and very useful paradigm is dash V, is when you want to mount a path on your local machine to your container. So if it hasn't been clear so far, this is something again to sort of drive home is these containers are standalone, right? When a container spins up, it has zero access to anything on your local machine apart from compute and memory, which is orchestrated from Docker Desktop, right? It cannot access any files that are on your local machine. It cannot access any environment settings, any passwords, nothing. It's a completely self-contained system. And it's ephemeral, right? That means when you spin it down and delete it, anything within the container is gone forever. So if you open up rvar, which is a base R, and you start R in it, so we say we do this, and now we start R, and now we start programming in R, and say we save something in the container, right? We save a model or a CSV file. The moment we exit and that container is gone, everything is gone within it, right? Everything within the container is not stored because it has no access to your local disk space. So one way to enable that is to do dash V. That means, hey, I want you to start this container and I want you to give it access to this folder. So I've put this folder, which is the folder that we are working in. So this is on my local machine. And the colon is, I want you to mount this at this path within the container. And the rest of it you've already seen before. So if we copy and paste this, now we are back in an active container. And you'll see that the SHA is always here. So you can see that, what the SHA is. And now if you see ls and we go to home and do an ls, you'll see work, right? And if you go to work and you do an ls, you'll see the contents that are on my local machine here. Okay, now this is interacting directly with the local. So if I do something here, right? Oops. Right, and I create a file, you see that it's actually created a file here, right? Because it's on my local machine. And if I make a change on the local machine and save it, yeah, you'll see it here, right? Because it's now interacting directly with local machine. So this is the way that we mount local folders within Docker to use. And you do this for all the use cases where you're actively developing. Like if you're using RStudio or you're using VS Code and you want to develop in Docker, you want to mount the location of your project folder within some folder in the container, and so you can work on it. Okay, before I keep going, are there any questions on this so far, Rami?
Oh, there are two questions. There was a question, I don't see it anymore on the chat, from Natalia about she's trying to run the Docker CLI. And I believe the error she's getting related, I'm not sure if you push the images to Docker R. It's trying.
Gotcha. No, that's a good question. So I haven't. So none of these, the Docker for R / images are pushed to Docker Hub. And we can do that maybe after this session is done. If you'd like, we can, in which case we'll have to create an account called Docker for R and we can push it. So the way you would make any of these for like across the board, any of this that you want to make is we've included Docker files. So each folder has the Docker file and you would build it. So in this case, for example, it would be essentially this Docker build or Docker for all build, say test. So Docker build tag, right? And that's how you'd get the first image. Any other questions, Rami?
Yeah, so I think in line of this question, if you will build, Natalia, if you build this Docker on your machine, then it's usually like what Docker does. It's look first, does this image available on the machine? Not will go by default to Docker Hub. That's the first place, unless you log in to another something similar that you can access images. So I recommend just build the Dockers and then you can run it. There is another question from Lucas. Do you need to create the work directory on the Docker file before mapping the volume?
No, you don't. So for example, in this Docker file, right, we only created the scripts directory, right? But over here, we are mounting it to work, which we haven't created. And so if you look in here, we have it's mounted to work, right? And if let's prove that to ourselves. So if we run this command where we haven't mounted anything, it's the same same Docker image. If we go to home, it will be empty, right? So you don't have to do that beforehand. Okay. So the last very useful argument is -p. Okay, so -p opens a port from your local machine to the port in the container. Okay, and so this port is a way for you to be able to expose an app or a service, right? So what this is saying is, hey, Docker run, and on my local machine, I want you to map port 8787 to port 8787 inside the container, okay, for RStudio. So this is a very typical paradigm to be running RStudio, okay? Remember, -e was environment variable, and RStudio expects you to set some password. And so if you run this, again, Rocker/RStudio is an image that's online that has RStudio on it. And we'll look at Rocker images in a little bit. So if you're curious as to what this is, we'll cover it, don't worry. But for now, just consider that it's an image that has RStudio in it. So if you run this, right, a whole bunch of things happen. Let's see if there's some very important bits in there. We ran that, and you'd end up seeing something like starting services and done, right? It's sort of very anticlimactic again. But what's happened is you'll notice two things. One is I did not get my command line back, right? Because we didn't do -d. So it's not a detached container. This is now actually running. And now if we go to Safari,
Oh, we cannot hear you. I think we lost again, Raul. So I think if I need to guess what's going on, and that's another thing to be aware about Docker, is the resource allocation. If you over allocate resource, then you're leaving less resource for your own machine to run, and especially when you're running video, that might be challenging. I see we've got Raul back. Raul, I believe that we cannot hear you, so maybe stop sharing and return. We try to text him. Raul, if you can hear me, we cannot hear you. Can you hear me, Raul?
I can hear you.
Yeah, I think that once you started to run the RStudio, we lost you. I wonder like how much resource you allocate for your Docker.
That's interesting. Okay. So was that seconds or was that minutes? Because I kept talking.
That's from the moment you try to log into the RStudio server.
Oh no. Okay. I'm glad you called. All right. So I have maxed out.
Oh, why don't
Maybe
you?
I'll take it back. I'll take it back. Okay. So this is let me apply and restart. Yeah. So folks, it's maxed out because we are running some production grade containers at work, and even the 56 gigs I have on this machine is less for that. So maybe that's why it's like hanging up. Till it comes back up, I'm going to go back to VS Code and tell me where it is. Was it
If you can show
here?
again, log into the RStudio server. Yes.
Yeah. Okay.
And
So
we
after
got
that,
3
I
more
went
minutes.
through.
Oh,
We have 3 more minutes.
yeah, but just be aware that we need to go to a break sometime in a couple of minutes.
So I'm going to, I think you guys missed Docker PS stuff. So let me just talk about Docker PS. So Docker PS is essentially listing all the running Docker containers. So for example, here's the command Docker PS, but this now has -- all as well. And what I was saying, and I think you guys didn't see it, was I ran a container that was actively running. And so in this Docker PS, you can see the name of the container and you can see the status, and it says 9 seconds. So it's up 9 seconds ago. And here's the ports that are mapped. And you can see all these lists of containers that are exited. So these are containers that existed at some point and we stopped them, but they are still cached. So it's possible for you to continue running on a cached container. And I was saying that that's where this --rm comes from. Like if you have --rm, you're telling it, after I'm done, don't bother caching. If you don't have --rm, after you X out, it's going to cache this container and just keep it for you, right? So depending on your use case, you may care about it or not. Okay. Now, before I can run anything else, I hope Docker desktop is up again. Okay. Yes. Okay. If you guys are still with me, I'm going to cover Docker exec now. So Docker exec is another very useful command, and this allows you to execute a command on an already running Docker container. Okay, so I'm going to start by doing something that you've already seen so far. Docker run -d detached. Here's a port and I'm creating an environment variable foo equals bar. I'm going to give this new argument name go blue, which I'll show you why. And I'm running Rocker RStudio. So this part you've seen already. Rami, keep talking to me in case you can't see anything again. Okay, so I've already used go blue. Let me use go blue underscore.
You're still there.
Okay, good. I'm still there. Okay, good. Okay, so so now what I've done is I've started a new Docker container. So if I do Docker PS, you'll see it. The dash name is useful if instead of the random name that's generated, you want to give it your own name. You can do that, and it's very useful when you're programmatically trying to do things. You need a name that you can rely on. So we did Docker PS. Now this is an actively running container. And Docker exec allows you to do stuff in it. So in this container, if you want to peek in, and this is very similar to like if you have a server and you SSH into the server, this is exactly that. So you can do Docker exec IT. I want to go into Go Blue 2, and I want to start bash, right? And it's exactly the same. The only difference between this and what we did before was before when we put it in line with the Docker run, the moment we exited out, the container stopped, right? Because that was in line with the Docker run. You're saying, I'm done. Docker exec is there's an active container and I want to peek into it. And so even after you exit out, the container is still running, right? You've not stopped the container. So that's a useful case for Docker exec. Very useful if you're like doing things within, creating directories, creating these things and that, and you want to like peek in and have a look.
Also useful for debugging.
Very useful for debugging. Okay, the last thing I'm going to talk about is Docker Compose. Okay, and this is my favorite part, so I'm very happy to talk about it. Okay, so Docker Compose is something, I was going to say fairly new, but it might be old now, where you're able to create all these arguments that you're passing to the service. You're able to put that in a file as a YAML file. Okay, and again, this is a very simplistic explanation of Docker Compose. It has a lot of complexity and a very large use case, but I'm not going to go into the complexity. I want to keep it simple. So here what you'll see is, here's a doc. I'm going to open this on the side and open this here. You'll see a sort of 1:1 mapping between what we typically do in a Docker run and the Docker Compose. You're saying, hey, I want to start a service. That's a terminology in Docker Compose. I want to call it, say, my RStudio. And I want the image to be RStudio, Docker RStudio 4.2, which is what we gave here. Okay. And I want ports 8787 to 8787, which is the -p. And I want some environment variables, which is what we did here, right? And I want to bind a volume, which is this source and this target. So source is on my local machine, target is within the container, right? And I'm going to save this as a Docker Compose.yaml file. And now it makes things so much easier because A, you don't have to type this out. B, you can keep this one file and version control. You're essentially able to version control the command itself, in a sense. And then starting something up is very easy because you do Docker Compose up. And it's going to read all that and start up. And the reason it is failing is because I have 8787 already allocated because I have this running container. So that port is already used up. So let me stop that and do a Docker Compose up. And what it's going to do is essentially going to do that. It's going to read it and start the service. Again, if we go to 8787 localhost, you'll see RStudio. No difference from what we did before. It's going to mount the volumes, etc. So this is very, very powerful to do a lot of things. Downstream, when you get complex, you can have multiple services. So you can have an RStudio service, you can have a Postgres, say, database service, and you can have something else. And you can have dependencies. You say, hey, I want you to first start the Postgres service in Docker. And once the database is up, only then I want you to start my RStudio service. So you can start like doing complex stuff like that. The rest of these, I won't run through just for time, but self-explanatory, list the containers. You can again start this in detached mode, right? Like here, my terminal was tied up, but I can do a -d. So everything happens in the back end and I get my terminal back. And then I can do Docker Compose stop, and it's going to essentially stop the service. Very similar to what we've seen before.
Can you just show before going to the break the RStudio server?
Yeah, oh, sorry, since we didn't see that the last time, I think, let me start that again. So again, I did Docker Compose of -d. We have started this and we have mounted a volume. So now if I go back to Safari,
I think it's maybe something with the Safari. We lost all again. So I see there are I will answer questions until we get Raul back. So I see one question from Rakesh. is it possible to communicate with external database from inside the Docker container? In the same context, is it possible to interact with a running Docker container from another Docker? And the answer is yes. This is a very useful and common application that you are, especially with R, that you are pulling a Docker, one Docker of R, like let's say the Rocker that we show, and then you're pulling a second Docker with Postgres. And I think Raul is not aware that we lost him, so let me just try to ping him. Raul, we lost you again. I don't know if you can hear me.
I can hear you. Okay, so
I'm answering a question. So yes, the short answer, you can connect with other database, and there are a lot of, if you go to Docker Hub, you can see like the main one, you have Postgres is one of the most popular, MongoDB, and essentially every type of database you would probably find in Docker that you can mount to another Docker that you are running. So yes, that's there was another question about let me try to find it. The files created by the container are typically written with root permissions. How do you normally set files permission for the container so that the host can work with the output files? Or do you want to take it?
yeah, Manoj, I've delved into this only a little bit. I have some sample code that I can't go into now because I haven't done this too much to talk about it. But you can essentially create a username for the Docker and change the active user when you launch the container, so that when you write files, it's by that user. I have some code somewhere, so I can take this as an action item and we can put it in an issue or update it somewhere.
And I think there are no any other. Oh, I see. I see Natalia solved the issue. Great. There is another question about disable auth on the chat. Presumably stop our student needing a password. Yes. So you don't want to, if you are, in a safe environment, and typically, it's like you are setting the password is exposed, so it doesn't make any difference if you're on it locally. So you can set it as disable it and just access it directly. So I think if there are no any other questions, we can take a 10 minutes break and return it. Now it's here almost 4 and 10 minutes Pacific time, so we can return in 4:20 Pacific time, so in 10 minutes.
All right.
And after the break, we have on the agenda, so we cover the Docker command lines, and
we have the Docker and R basics, the intermediate concepts. So we are doing good on time. Now we are, I think, 10 minutes behind our allocated time. But I think we're having a good discussion. And I think, Rami, what's happening consistently is every time I think I try to do the local host, this is stopping.
Yeah, that's the pattern.
That's the pattern. But I think this shouldn't affect us because everything later is in video. I'm going to do a screen share for the timer. And there you go. Since we started 9 minutes ago.
Can you full screen it?
Yeah. I'm just going to go on mute for a while.
If there are any other questions, feel free to put it on the Q&A and we can address them after the break.
All right, and we're back. Can you guys hear me? I'm still here.
Yeah.
All right. I'm going to try and avoid doing our studio
Trying
now.
to do crazy stuff.
There you go. Okay, so I'm going to start again. We're going to go into Docker and R basics now. So the intent is to spend maybe roughly 45 minutes on this. If needed, I can go a little bit faster so we can hit some of those intermediate advanced things as well. I'm going to cover, look at the Rocker project and just give you an overview for that. Then we're going to look at installing packages in the Docker image. And there are four ways, sort of four different paradigms that we have at least found so far and we are sort of actively using. Developing in Docker with RStudio IDE, deploying models in Docker with the Plumber API, and then deploying Shiny apps in Docker, right? And all of this is going to be in VS Code. I've reproducible examples for all, and we can discuss those, go through some questions, and then move on to the next one. So let's start with Rocker. You've already seen this a
Oh, we lost you again, your sound.
Oh. Any better? I haven't
Yeah.
changed anything on my, yeah. Sorry, folks. I'm not sure how to fix things on my end. If you have ideas, I'm all ears.
Do you want me to cover the Rocker?
Hear me? Can't hear me, can you? Okay.
Yeah, we can hear you now.
All right. Maybe I'll keep my video off. Maybe this is a bandwidth issue.
No, I think if you are speaking, we cannot hear you.
I'm gonna start. Okay.
Yeah, I can take the Rocker. So let me pull the Rocker while Raul will restart his machine. So essentially, there are a couple ways to work in R and Docker, but the most robust, in my opinion, is if you can someone confirm that you can hear me?
Yes.
All right, perfect. Just confirm that we don't have the same issue. All right, so essentially, you can go and build your own images, but there are advantages of this. But the more robust method, in my mind, is to use the Rocker images, and the main reason that it's a well robust and tested by the majority of the community of the R users. So you can know that if you're using this Docker, it's tested, and the chances that you will have some issue is low. And if you have issue, you can go to the project and file issue and try to solve it. So the Rocker project is a wonderful project that running by those three foxes mainly, but there are others that contribute, Carl, Derek, and Noam. And essentially, the goal is to create Docker containers for our environment. And so they are providing a bunch of Dockers. If you go to Docker Hub and look for Rocker, you can see a full list of images. Let's see if they have their. Let me increase the screen. So they have they have for the variety
Rami?
of yes.
I saw a message that they can only see a black rectangle on the screen. Can other folks see your screen? Okay. It sounds like this could be a platform issue.
Let me stop sharing and so let's try to
Rami,
reshare.
try
And if
one more
not,
thing. Maybe turn your video off and see if that helps.
yeah, I don't think I should have any issue, but let's try this. I believe maybe it's a platform issue. So within the Rocker platform, you can find a variety of Dockers from the most R developer, which is the most recent R version that's still on development, to the stable versions, a Tidyverse, Docker RStudio. So the one that Raul showed before, it's coming from the Rocker RStudio, and variety of applications. So ML, I assume that's for with machine learning. If you go and see Rocker Stack for machine learning. So I think there are core machine learning packages that are already pre-installed, and for each Rocker image, you can see like what is the command that you go and do a pull. And if you go to the GitHub page of Rocker, you can see all the versions and some data about what was the recent build time, how many downloads, and so on. So Rocker, if you're starting now with Docker, I would recommend to go and start with Rocker. I also recommend for learning, for your own learning experience, go and try to build by yourself, install R on a Docker, on a clean Docker. That's the best experience. But if you are working on a project, I wouldn't try if you don't have experience to install by yourself, and I would go to Rocker. That's the robust approach.
Thanks, Rami. I'm going to try and yeah, I'll share my screen, but you have to stop, and then I'm going to move to VS Code. Let me know if you can see it.
Yes, we can.
Okay. Okay, so the what I want to cover here is let's start by installing R packages. So there are four ways, these sort of four paradigms, going from very simple but not so great, which is using install.packages, to using something like mran and then renv. And there are two approaches in renv that I want to talk about. Okay, so we'll start with a simple one, just install.packages on mran. And so later you can see this in the 0.4 Docker and R, 0.2 installing R packages, and just using command line. Okay, so I'm in this folder now. Let me go to 0.2a in command line. Okay, and so there's a bunch of commands here that I have. The first one, let's look at the Docker file. Okay, so here all I'm doing is a very simple example. We are starting with Rocker R-ver, which is just again R with some packages, 4.2.0. Okay, we're adding a label. And then I'm showing you two ways of just installing packages, right? One is your install.packages that we use in R, right? And the way you can do it is using rscript-e. So rscript is saying, hey, run this rscript, and the -e is, I have a command for you, an R command, and then install.packages CLI, right? So this is just what you would do in R anyway. Another way is to use this install2.r, which is, I won't delve into it, but there's this a package called Littler, Littler, and I have the link in resources that has a bunch of these very useful sort of shell commands to install packages. So this is doing exactly sort of the same thing, install2.r, and I'm installing text plot, right? So I'm installing two packages. Pretty straightforward. The way we would build this is everything that you've seen before, nothing new, is docker build. Dot means the stuff that's in this directory, so it'll go and file the Docker file. And the -t is the tag, and I'm giving it a name, package example simple. Okay, so I can execute that here, right? And it's going to go, and it's again using cache because I've run this before. Otherwise, it takes a little bit of time to run, and it'll be done. Now this is very easy. You can even check that things are running by running this check script, where all it is doing is it is running our script, and I'm checking package version for CLI and package version for TextPlot. Now, because the reason this is not so great is because I'm not controlling the package version, and I'm not locking down the package version. So while the package version today for CLI is 330 and for TextPlot is 104, if I ran this 3 months later, I'm not assured that I'll get the same exact package versions, which defeats the purpose of reproducibility, right? Where we want to lock everything down. So while this is the trivial example, this is what we don't want to do. Okay, so there's one improvement to it is using MRAN. Okay, now what is MRAN? Let me show you in the browser.
Rahul, are you still there?
Yeah, I'm still here. Can you hear me?
Okay. Yeah, we can hear you.
Okay, it sounds like it's a little bit glitchy, so just keep letting me know.
I think we lost you again. Do you want me maybe to share and you can?
Let me try one more thing. Let me try keeping this side by side. There's ideas that Safari is a problem or it goes silent when a new browser window is opened, which are fair ideas. Can you see things side by? If I just keep it separate as an open window, are you able to still see?
Yeah.
Okay. Sorry, folks. I'll tell you, I can try Chrome downstream a little bit, but I have nothing set up in Chrome. None of my passwords. So I tried logging in, and I'm starting from scratch on Chrome. So I prefer like not changing browsers midstream. Let me know if this gets worse. So MRAN, I was saying, was basically a daily snapshot. So every day there's a snapshot taken, and you can reference these snapshots with a date. Okay. So here's an example. Again, we're starting with the base R, and I'm making an environment variable, and I'm setting it to like 1st of Jan 2021. Okay. And now I'm going to do the install.packages, but instead of the CRAN repo, I'm giving this MRAN repo, cran.microsoft.com/snapshot/ whatever this date is. Okay. And I'm again doing that with this way or this way. Same thing. The -r is use this repo. Okay, and what all this is going to do, as you'd expect, is it's going to go and it's going to use whatever the packages were, the versions on that one date, right? And so we can check that if we do check, right? Remember, we were at 3.2.0 previously, which is the current version. Now this is installed 2.2.0, right? So mran's great. We're at least able to now lock down the package version by date. Okay, so pros and cons, we're at least better than where we were. The cons are you still can't lock down specific package versions if you really care about it, right? And you also depend on Microsoft keeping MRAN alive, which, I mean, they would, but you have this dependency, right, of MRAN. Okay, so this is another way to do things a little better than we were before. Okay. Option 3 is using RENV. Okay, so if maybe we should have put this in the poll, but are folks aware of what RENV is, or should I give a little blurb about it? Let me assume that y'all haven't used RENV, and I'll give a quick blurb. But it's a very useful package developed by folks at RStudio that helps you lock down project-specific dependencies, package dependencies, okay, to ensure full reproducibility from a package perspective. Okay, so at a high level, what you end up creating is something like this, like a lock file. Okay, and this is going to be a JSON load of all the packages and the version number for the package. So now we have switched from using that date-based approach to saying, hey, I want this package and this particular version, this package and this particular version. All right. And so the way we're going to create this Docker image is slightly different. So we're going to start with our base image, right? And we're going to assume, and this is a good practice, that RENV isn't installed. So we're going to first install RENV, which is true for our Word doesn't have RENV. So I'm going to lock down a package version, say RENV 0.15.5. I'm going to install remotes package, and then use the remotes install GitHub RStudio/RENV @ and then the package version. Now, this really brilliant piece of code is not mine. I cannot take any credit for this. This is actually the recommended approach on RN's own documentation, right? So this will always ensure that you get RENV 0.15.5, right? So far, no matter when we run this in the future, we at least are ensured 0.15.5 for RENV, okay? Now we create a working directory, say called RENV. You can call it whatever you like. And then we're going to copy this lock file. So copy RENV lock to RENV lock. And it's going to copy it in this /RENV, because working directory, this command, remember, creates a directory and then changes to that directory. So in the container, you have to imagine that now we are in this and we're creating this. And the last command we run is RENV restore. It's going to run it in that directory. And what RENV restore does is it says, okay, great, I'm going to go look for a lock file, and I'm going to start installing all of these guys. Okay, so let's build it. The build command is no different. Docker build -t, and I'm going to call it package example RENV1. Okay. So again, it runs quickly because things are cached, but it runs those layers. There are now 6 layers. Okay. And now we can look at it. So for example, if you do docker run rmit docker for r package example RENV1 version 1.0 bash. Okay, let me just zoom in a little bit in case. So now we are in here. Notice one thing, that since we use workdir and RN, we actually started in that directory. If we do ls, you'll see the RN block file. And now if you go to R and open up R and you use, I believe, package version R6, you'll see that we have 251, And if you use box, you'll see that we have 112. Okay, so it works. So we're now able to lock down package versions, which is very critical. Okay, so this is at a minimum what you should be using between MRAN and RN. Choose one. But at a bare minimum, this will ensure that your packages are locked down and your Docker image is fully reproducible. Okay, so this approach is, again, I've labeled it here. It's called like install packages when the Docker image is built, right? Because what are we doing? When is this built? The packages are installed at build time, right? When we run that build command, that's when you're actually copying log file init and you're also running rm restore. So all the packages are now inside the Docker image and they're ready to go. Okay. What are the cons of this is if you change the rn file and you say make this 2, for example, right? When you have to rebuild it. You cannot just use your old build because the old build will have 251. So if you change it to 252, you have to rebuild it. Does that make sense? So this is how you use rn. And there's a question before, I forget what the exact question was, but does rn replace Docker, or does Docker replace rn? And the answer is no. I think they work very complementary with each other if you adopt a solution like this. Okay. Now there's a fourth option, which is maybe an edge case to some people, but I want to put it out there. You may or may not use it. And just to aid understanding of that, I'm just going to open up Keynote again. So we talked about these 3 options. The difference between option 3 and option 4 is option 3 right now we saw is install the packages when the Docker image is built. Option 4 is install the packages when the Docker container is run. And the only difference being that it's possible to keep a local cache for rn. Okay. So instead of having to download the packages each time you compile, say you have 50, 100 packages, maybe it takes 20, 30 minutes for everything to run. You can keep a local cache of rn on your local machine. And then you mount it as a volume to the container, right? And then once the container starts, the container is going to know, oh, hey, where's my R packages? It's in this mount. And so what happens is you could have, 10, 15, 20 containers referencing one central cache. And you can use that. Now, in the interest of time, I'm going to move on. I won't delve into this more than it is because it does require a little bit of orchestration, but the reproducible code is there. I'll move to developing in Docker and models, which I feel is much more relevant. And then if we have time, we can come back to it. All right. And if you have questions and it's beyond the workshop, just open a GitHub issue and we'll be happy to answer questions. Okay. Moving to 3. So we looked at installation of our packages. Now there's sort of 3 use cases: developing in Docker and then deploying in Docker. The developing in Docker bit, I'm going to go through pretty quickly because we've already seen it. It's essentially connecting to RStudio, for example, as an IDE. So you can start with an image that has RStudio. Here I'm combining this new information of, say, I'm installing data.table in RStudio, and then I'm going to run it. Build command doesn't change, right? You just give it some namespace and tag. Run command doesn't change from what we saw before. You have to make sure that you give it a port, which we did. You can disable auth if required. Definitely want to mount a local volume, and then you run it. All right. I won't run this again in the interest of time, and because every time I run RStudio, things stop working for some reason, right? But this is no different than what we already saw before with RStudio. It's going to open up RStudio, then you can open up a browser and just develop like normal. So we saw that. These are two new use cases of Docker and R, right? So far, 03 was developing the code, but what happens when you have something that's developed and you want to deploy it in Docker? So here's two examples. Let's look at 04, okay? So here's an example where maybe you have a linear model. So I've built a model here, right? Build model. Think of this as any machine learning model or something. You have some object that you have built. So here I'm regressing MPG over cylinders and displacement for empty cars. I have this object and I'm going to just save it locally, right? So in your head, replace this by your entire model. And now you have, say, an RDS object or a QoS object. And you want to just predict against this. So you want the ability to have a user pass some values. I want to now pull this model, give it the values, create a prediction, and serve that prediction back to the user. Okay. There's a couple of ways you can do this. You might want to say, write the prediction back as a CSV, or write the prediction back to a database. Or in this example, I'm going to give it back as, I believe, as like a JSON payload. Okay. So this solution is using this package called Plumber. And what Plumber allows us to create is an API. So if I go back here, Plumber R, here you go. So this is the documentation. I'm certainly not a Plumber expert. I can make do with it and create things that I need to. But at a high level, what you're doing is you're able to create different functions, just like you have functions in R, no different, but be able to service them as an API. So I'll show you an example of that. So what we've done so far is pretty simple, no different. We have saved this lmmodel.rds in our model folder. Okay. Now this is the Plumber part of it. There are two files that I want to show you before we build the Docker image. The first file actually runs Plumber. So you're calling Plumber as a library. Then you're just reading in the RDS file, lmrds. And this is a very Plumber specific. PR is, I think, a Plumber run or a pipeline run is, I think, what PR means, right? And you're saying, I want you to take whatever is in this predict.r, they're the functions, and I want you to run it as an API exposed on port 8000. Okay. And what's our function? I've just created one function, very simple. Okay. You pass it cylinders, displacement, and horsepower. And these are going to be coming as characters or strings from the API. So I'm doing it as numeric, saving it as a data frame called new data. And I'm just doing predict LM model new data, right? Very, very standard. What we expect from predict is the prediction value, right? And this is saved as a function. And all of this decoration on top is Plumber specific syntax to say these are the parameters and this is going to be a post method. And I won't get into that, but read up on Plumber API and you'll see it. Okay. The Docker file for this is interesting. So here I'm starting with a slightly different image, RStudio Plumber. What I found that you can start with the base image and then install Plumber, but there's quite a bit of payload and it takes a while to run. RStudio has a base image called Plumber. It's very easy to just get started, but you don't have to use it. Okay. I'm creating a work directory called Plumber. So it creates a directory and moves in. And I'm copying three files. I'm copying model, what's in model, LM model. I'm copying the Plumber R file, and I'm copying the predict file. Exposing a port 8000. And again, this entry point is, it's run this at the end. So it's running R script and it's sourcing this Plum model, which is this file that we saw. So at the end of it, it's going to really just source this. That's all it means. Okay. The build command is exactly the same, no different. So if we go to now 04 and I build, it's going to go and build it. And then the run command, I have it in the README, is again no different than what you have seen before. Let me just copy this and you can see it. It's Docker run, and I'm exposing a port because we chose 8,000, right? And what this is going to do is it's going to now source that file, and just to confirm, I put in this message running plum model.r. You see that here. So what is done is it's sourcing this file, which calls library plumber, reads in the model, and now this is now hosted at this location. And now if you click this, you can actually see the Swagger. Since I opened up a browser window, are you guys still there? Rami, can you confirm you can still hear me, see me?
Yeah, you're still there. Don't go full screen.
Okay, I won't do full screen. So here you see that there's a method predict. You can open it. You can, of course, have documentation and stuff. And now you can actually try this API right away. So you say, hey, 4 cylinders, 150 horsepower, displacement, 300 horsepower, right? And if you hit execute, it's going to actually run the prediction function. And let's confirm that. So in the prediction function, which was predict.r, I had called the message. I said message running prediction function with so and so and so. And you can see that. So when I hit execute, it's actually running this function. It takes in the 3 values that we gave it, and it returns a prediction, right? So this is one way of deploying a model. And now, abstract it out. So here's a framework where you can use Plumber to put in an object and do stuff with it. You can now expand this to any machine learning models, multiple models, perhaps ETL pipelines where you have data and you have scripts that can touch different databases, and you have some ETL scripts that are now functions within Plumber, and you can have an API that goes and calls it. It sources data, runs transformations, maybe model, data cleanup, and then gives the user clean data, right? What have you? You can, expand it. So this is an example of how we can deploy models in Docker using Plumber. Now, the advantage of this, again, going back to Docker, is this is now standalone, right? This entire thing is standalone. So this particular one is going to run here. It's going to run on Linux. It's going to run on macOS. It's going to run on Windows. It doesn't matter. It will run on a server exactly the same because it's completely self-contained. I have one last example in this. Rami, how am I doing on time and questions?
I don't see any questions. I think you have a couple of more minutes and then we can go to the next topic.
Okay.
Last topic.
So the last one here is deploying Shiny. So let me go to Shiny. So here I've put an app called My App. This is the very typical example faithful user data app. There's no change in the app itself in this folder called My App. Again, extend this to this folder can contain your entire Shiny application. Okay. The Docker file, I'm using again a slightly different base image, Docker Shiny, which has Shiny pre-installed. You don't have to use it. You can build it on your own. It just takes a while to compile. This is easy to get started. So I'm using it. And the only things we are doing is copying the app. So I'm creating a work directory home/app, and I'm copying everything in My App within there. We're exposing 3838, which is the port we have selected for Shiny. And at the end, we are running a command. So you're setting this option saying, hey, I want to set the port to 3838. And I don't recall if by default it's always 3838. So this you really have to do if you want something specific like 3839. But I've had a habit of just using it this way. Followed by the command Shiny app run app, right? That's a Docker file. The Docker build is again no different. You have this Docker tag of, I'm calling it Shiny development. There's this new argument that Rami showed me yesterday, which was pretty cool. So I put it in here. So let's look at it. Yeah, we are in here. So if I run Docker build, this progress equals plain gives you this very plain way. So if I scroll up and do we have another example? We don't. Remember how the other ones had this very like nice sort of output that was condensed, but the progress equals plain actually prints out a lot of metadata of each layer, which is really nice. And I feel this is much better for like logging if you had to log this in some sort of pipeline. Okay, so we've now built the image that has the app in it. And instead of doing the Docker run, now I've given an example of Docker Compose up. And so the Docker Compose up for this is very straightforward. I have an image and I'm exposing a port, and that's really it. So instead of doing Docker run, we can do Docker Compose up. And it started is run that command that we needed to, which is now listening on 3838. So this is where I go back and I hope that it doesn't crash things. 3838. Right, and here's our Shiny app that's fully running, right? So this is how you'll deploy Shiny. And now put all these concepts together, right? Because right now we didn't mount a volume, but if you had a Shiny app where you want to keep data back onto the disk, just mount another volume, and now you can write to that volume. And that's one way. I think there was a question somewhere, can we have a Docker container talk to another Docker container or a database that's running in a Docker container? And you can do that. And you can use Docker Compose to help orchestrate this. So you could have the Shiny app and you have some data and you hit save and it writes it to the database. That's also possible, right? So these are just like the nuts and pieces. Okay, and that concludes this section on Docker and R. So just to recap, we looked at Rocker very briefly. We looked at a couple of ways of installing R packages using mran. The command line way is the bad way. Mran at a minimum. Rn is a great option. And there are two ways. You could do option 2 with the local cache if you need to. Developing in Docker, I remember we saw was using RStudio, exposing a port, and when you do Docker Compose up or run, you can now develop. We saw deployment of models using Plumber, and then Shiny. So with this, I can happy to take questions, or if you're in interest of time, if you want to move to the next section, Rami, we can.
I think if there are any questions, that's a good time for moving to the next one. I think people are overwhelmed.
Yeah, I will say, let me pitch in. I feel like we are throwing like the kitchen sink at y'all because there's so much. So, absorb it at your own pace. We've tried our best to document everything in the GitHub repo and make all the examples fully reproducible. If you face an issue on any of those examples, and especially I suspect Windows users you may face, because me and Rami are not Windows users. So if there are some caveats or something has to be set up a little bit differently, like open an issue and we'll try our best to like get you over the hurdle.
Okay, so I think there are no any other questions, so we can move forward and to the last topic. And let's just share. Okay, and Raul, if you can mute, we can hear your keyboard.
Sorry.
That's okay. So the last topic that we want to cover is more like applicable, like applications, like what you can do with Docker and how to set VS Code with R. And if we have time to talk about Postgres and there was a question, so hopefully we get into it. If not, I think there is some documentation that we left on the repo. So I think what drove me to my open source project to Docker is the use case with GitHub Action, which for those who don't familiar with GitHub Action is a great tool that GitHub provides for free that enables you to run cron jobs and other jobs that you want to run within your repository. So we had an example that I created, like a package template, but I think it's not fully ready. So I will go over a real example that I'm using it in a project under the coronavirus package. So the coronavirus package, as the name implies, is a package that provides tidy data of the COVID-19 cases around the world using the John Hopkins repository.
Rami, sorry to interrupt, but could you zoom in quite a bit?
Yeah. Thank you. So the reasoning I started to use Docker in this package was related to data refresh. So when the whole process started, I just provide the data on a daily basis, trying to find if there is any. Essentially, in the beginning, I refreshed the data manually until I realized I cannot do it every day. And then the solution I found was GitHub Action. And GitHub Action, it just enables you to schedule work. And I started with manually set the environment, and then it was painful. And that's what drove me to use Docker. So essentially, since then, on any package that I'm creating, by default, I'm using the skeleton, and then I adding the Docker folder. And over here, I add different folders for different Dockers. That's a bit an old example, but essentially, that's the structure that I'm using. So dev is where I'm developing the Docker and testing it. And it's aligned with the package version. So while I'm in a development mode of the package, I'm starting a new tag. I'm also starting a new tag on the develop folder. Prod is once I set the package, I'm releasing the package to Crane, so I'm setting a fixed tag and I'm moving into prod. And that's the development is just environment. There's no RStudio. And RStudio is where I'm adding the dev to the RStudio Docker, and from there I'm essentially developing inside the Docker. So any error that I will get inside the RStudio, it will be also inside Actions because I'm using the same environment, and this is the main advantage of this. And test folders where I'm having a Docker file when I want to test a new feature without rerun the whole dev to build it from scratch. So I'm just using it in test it just for saving time, and then once I can see that I can run it, I move it back to the development. So that's kind of like the workflow. You can go and clone it and run it by yourself, but one thing to emphasize here is usually the structure that I'm using. There is a Docker file, like I will show on the examples, and I have some bash script build Docker, which I'm using it just to build the Docker and push it, which is essentially like Docker Compose, not Docker Compose, it's like because I'm building, but it is build and push of the Docker itself. And I have, in this example, a script that I'm installing the requirements and testing that it's installed everything. It's an old script, so it's not the most efficient script. If I would do it today, I would use the renv example that whole show, which is much more robust. So now let's go to see the applications. On actions, or maybe I'll go to the code. So any actions that you're creating, it will be hosted under .github workflows. So in this case, I have two workflows. One is main, which is running checks on any push that I am pushing, or pull request, which will run RCMD check. And essentially, this gives you indication if it's failed. So I'm getting an email saying that what I pushed didn't pass the test. And as you can see, that's a simple YAML file structure with parameters. And I won't go into too much details, but you can see what I'm asking from GitHub Actions. Give me Ubuntu, the same version that I'm using. And then I'm telling which Docker to use as the environment. So this is running on top of this Ubuntu, and all the requirements are here. And now I'm defining steps. So the first steps, I'm checking out the repo. So I'm like cloning the repo. And then I'm running the check, which is like any command on the command line that we would run. And in this case, I'm running R script and the script that I want to run, which is the initial the CMD check. And you can go and see on the actions, have your different actions. So this is the RCMD, aligned with the name that I use. And you can see that all.
Rami?
Yes.
Sorry to interrupt again. Could you zoom in a little more?
Yeah.
Your screen's like some crazy resolution, Rami.
Oh, I guess it's a wide screen, so I see it as a big. But
yeah, I think you're on your really wide screen. So maybe one more plus would help.
Is it fine now?
I think that's a lot better. Yeah, that's better.
Okay.
Thank you.
So essentially, you can go and see, like, those are, anytime that I push code, you can see that, so there are cron jobs. So it's running, that's not the cron jobs, but anytime that I push some code, it's just run the RCMD, and this is like a normal routine, and this is, I did a merge, and it's, you saw, like, that's the commit. And if you go and zoom into the log under the check, and which is aligned to the step that we define as check, you can see R running the RCMD build and RCMD check. And you can get the log at the end, and you can understand what, if it's fail or not. And this is also, if you have a test that, if you have unit test, you run your unit test, and at the end, if it's passed, you will get, it's linked to this build telling you that it's passed. The other thing that I actually, it's much more exciting to do with GitHub Action is to run a pipeline. I won't go into too much details, but essentially, the other script here is refreshing the data. It's a cron job. It's running every 8 hours. And what it does is it's running on different branches. So you see here there are multiple steps, each related to, there is dev, staging, and the master branches. And it will run the refresh. And you can go and see so what it does, it's trigger, and then I probably should do zoom in. It's trigger,
yes, please.
our markdown. Is it okay now?
Yeah, this is better. Yep.
It's trigger R markdown that linked to the package website that you can see that it's refreshed the data. So this is ran essentially today, sometime today. The R markdown is a list set of functions defining parameters, and then it's running, pulling the data, testing the data, and at the end, it's return some log. Where is the log? which gives some status update. There was a new update, and was the code ran successfully. So those are two use cases. I can go more. There are other fun stuff. If you go to my GitHub page, if you go, there is the Italy dashboard, which is dashboard also Flex dashboard that refresh with GitHub action inside Docker, and it's every day provide a new. It's refresh the data for the COVID-19 cases in Italy, and there are a couple of other projects I can point out later on in the chat. So I will pause here before end off to all. Are there any questions?
So far, I don't see any. If you have questions, put them in. Till then, I'll answer Oliver's question. Why do we run R script -e and then source file instead of just R script and the name of file? And you can. You don't have to. The -e allows you to pass just R commands instead of just the file, and it's just a matter of habit. Like there's many times when we want to write a command and then source something, so it's become a matter of habit to do the -e, but you don't have to if you don't. Rami, Susanna has a question. I don't know it yet, but I understand there is a Flex dashboard thing which also does web API. Is it equally easy to combine with Docker?
Is it referring like that you are calling API through the Flex dashboard? I have an example of a Flex dashboard so Flex dashboard by itself, if you're not using Shiny server, cannot communicate with API. What you can do is with GitHub Action is run a cron job that go to the API, pull the data that you need for the Flex dashboard, re-render, and populate it inside GitHub pages. With GitHub pages, that's the easy way. If you have a Shiny server, so then you can do a live connection. But that's not. I'm not sure if you can do it within a Docker, because depending how you deploy, you can do it with Docker, but depending how you choose to deploy your Shiny application. I hope this is answering your question.
Patrice, she said yes, and Patrice has a question. What is the infrastructure behind GitHub Action? Is it provided by GitHub, and what are the limitations?
Yes, it's provided by GitHub. It is for free, unlimited, with some caveat, which I don't remember what are the caveats, but I think you can run as many jobs that you want. I think there is some caveat which I'm not sure. I never got, like, I'm running, if you go see the number of commits that I'm committing, so I'm generating commits on a daily basis that are running by those jobs. I'm not committing on a daily basis by myself. It's all cron jobs, so I pretty much heavily using this GitHub Actions application. I never got to any limitation.
All right. There's one question by Tyron. Can you talk a bit more about your development workflow? I get building an image once I have working code and know what packages I need. But how do you get to that stage? How often do you rebuild your image while developing? It's a good question.
It's a good question. There is more than one way. If you ask me, I'll probably give you 5 answers about how to do it. I kind of adopt, whenever I start a package, the first thing I open a Docker. I think, what are the packages that I need to have? I install it inside the Docker. I build a Docker, and then I mount it either to VS Code or to RStudio, and work inside RStudio. So any issue that you will get inside the Docker, this is the same issue that you will face after you deploy it. So that's kind of like create a parity, as opposed to deploying it on your local machine and then deploy it with Docker on some application like GitHub Action, and then you start to get error and you're not sure why you're getting it. So that's I think that's the best practice, to develop in the same environment and that you will deploy into your remote server. I hope this is answer your question. Raul, do you want maybe to go quickly on VS Code, and then we will pause for last question and summary?
Yeah, I do want to. And Kara, I see your question in the Q&A. I'll get to it right after this VS Code bit. Because we have 15 minutes, I do want to show you the VS Code part of things. It's going to be a bit rushed because, to be honest, the VS Code itself, that whole thing can be an hour-long presentation on the setup and all the options. However, we at least wanted to leave you with some reproducible work that you can read up and then expand on your own. So again, this is I've been using VS Code. For those who haven't seen this before, this is VS Code, and it's a really great IDE for development work, especially when you start doing R and Python and Shell and YAML and all of that together. There's a lot of extensions that make it extremely nice to use. In fact, Rami and I, we've switched over to using VS Code as our primary development environment. Now there's a way, so far I've been just working local. So everything, all of this, like this shell terminal is just on my local machine, right? But there is a way that you can set up VS Code to run where all your R commands and everything directly runs in a Docker container, which is extremely powerful. So you can use it as an IDE in that way. So I'm going to show you how. So in the 05 Denver environments in VS Code IDE is all the code to get started on it. Okay, so I'm going to open up this in a VS Code of its own. Hold on. So let me open 01 VS Code. Let me open that up. Okay, so I'm going to open up this folder, and you're going to notice something right away. Is because it's set up in a certain way, VS Code says, hey, this folder contains a dev container configuration file. Do you want to open up the folder to develop in a container? Okay, and I say, yes, that would be quite lovely. Now that's gone away, but you can redo it by reopen in container. And I'll go through what the setup is and what's going on here. So what's happening now in the backend is it is trying to open a container. That's interesting. Okay, so let's see what's happened.
I will check if you have any container running.
Yeah. Nope, I don't have anything running. Oh, yeah, the bind path doesn't exist because we renamed it 01 instead of 02. So that's an easy fix. Where am I? In Docker Compose. Yeah, this was 02. Now it's 01. So if I reopen in container, hopefully it goes well. So what's happening in the backend is it's starting a Docker container, and then it's going to attach the folder that I have in that container, and it's going to start. So let's confirm what's happened here. If we go back to our terminal, and if I do Docker PS, you're able to see the terminal?
Yeah.
Yeah. So you'll see that
Yeah.
I just started this container. The image is hat matrix / r underscore VS Code, right? 21 seconds ago. So VS Code started that container and it's attached to it. And you can confirm that by this blue little mark here, dev container, project container. Okay. And this is R now running in the container. Okay. And so I can start developing as we normally do. So if I have this test.r and I hit like command enter, it's going to start R and library R part. And now you start developing as you normally do. And everything is happening in the container. So this is very similar to where we had the RStudio IDE in the browser. And then everything that you would have executed in the browser in RStudio IDE would be actually running to an R process that's running inside the container. But now VS Code is doing this. Okay. So the purpose of this was to show you that A, it can be done, and this is how it is, and B, what is the setup. So I won't go through all of it because we might be lacking for time, but I'll walk you through the main components. Okay. The first one is you need a folder called .dev container. Okay. In that, you're going to have you can have these two files. One is called devcontainer.json. Okay, and this is essentially some configuration to tell VS Code that I am allowed to run in a container, and here's some details about it. So the key detail is in the Docker Compose file, which is what is the name of the image. So I have this Docker Compose file here, and it's all it's saying is I want to run this image, and this could be any of the other images that we've seen so far. You could have environment variables in this, just like before. You could have bind volumes, just like before. You could have all of that. You could have ports. You could have all of that, just like before. There's no difference. Okay, but this is dev container.json is a way for VS Code to know that it needs to keep track of this. The reason there are two, you'll see one in the root folder and one in the dev container folder, is for some advanced applications, you can start customizing. So you could have the one that's inside the dev container sort of override some of the settings, but don't worry about that for now. Okay. The other things that are really interesting and very useful is this extensions bit. So for those who haven't used VS Code, there's a whole bunch of extensions that you can add to VS Code to enhance your work experience. I mean, we are talking about not only themes, but you're talking about, like integration with Git and Git graph and things like that, right? Integration with databases, auto formatting. There's a whole bunch that you can do. By default, it doesn't inherit any of the extensions that are on your local machine. But this allows you to tell VS Code, hey, start the container, and I want all of these extensions by default. So it will automatically install them. The ones that you absolutely need at a minimum are these ones that are R. So without this, you cannot run R. So you need R editor support, LSP, and I think the debugger is optional. If you don't want a debugger, that's fine. But you need these other ones. And this allows you to then run R, and VS Code can talk to each other, right? The other thing that I feel you don't need it, but I want to show you in the .vs code settings.json. I feel this is my Rahul's opinionated settings, which are very useful. One of the annoyances of moving to VS Code is none of the shortcuts and commands that we are used to in RStudio work anymore, and it gets really frustrating. But this fixes some of that, and it just makes life a lot easier. So you can have a look at this, and I'm happy to delve into this later, but this at least gets you started. The last bit that I want to show you and talk about in here is Radian. So what you're seeing here is R, but it's not the traditional R. It's actually Radian, which I've installed here. And Radian is, if you have not seen it before, I'll put the link in the resources or on the chat. But it's, I think it's like a Python. What's the right word, Rami? Like a wrapper around R. Okay. And why would you use it? Because it's just a lot better than base R. It has, auto completion, that's a lot better. It essentially duplicates a lot of the RStudio magic on base R, right? How stuff works in RStudio, but if you're using just base R in the terminal, it's really frustrating. This gets rid of a lot of it. So it gives you, if you, I don't know what I have installed here, but it'll give you all of this kind of stuff.
5 more minutes.
Fair enough. So I'll stop here. That's a very, very quick overview on how to get started. For anyone who's using M1 processors, you're going to have issues with RStudio. VS Code is your way to go on Apple M1 processors until there's some stable version of VS Code, of RStudio for M1. Okay, with that, I'm going to stop sharing. And we can go to questions if there are any.
There is one question from Kara on the Q&A.
She says, how do you get your built image up onto Docker Hub to use it via GitHub Actions?
Oh, so that's, yeah, so you need to have a Docker Hub account. And then you need to log in. So you log in from the terminal. It's a simple login. It's require you for your user name and password, and that from there it's like acting like a Git command, like you're doing a Docker push, I believe is the command, and with the name of your image, and that's it. Once it's there, it's available for GitHub action. Or maybe we should add it to the documentation.
We'll put some links on documentation on how to get started on that. Are there any other open questions? Darren has a question. Also, Susanna has a question. Can you repeat why there are 2 Docker composes again, please? So without getting into details of that, you don't need to. You can keep one. The second Docker compose in dev container, you're able to add some very specific, like VS Code specific overrides if needed. And there's a script in VS Code where it'll set it up like that. I'll be honest, in the last 1 year of using VS Code, I've never had to like override anything. So I ignore it. I just keep it as it is. I'm assuming there's a use case where that's useful, but I haven't reached it yet. Darren has a question. Which parts of this do you put under version control? Looks like there were some absolute links in there. Does that cause an issue for collaboration? That's a good question. I think when you say this, I'm referring, it's probably some parts of the VS Code bit. I'll tell you our best practice. We put all of it under version control, right? Everything that you saw, all the dot files, Docker Compose, all of that. And the way we handle any path issues is we abstract it out. So I've put absolute paths today just for this session, but in prod, everything is a variable. So all our paths are environment variables that we save, right? And within a team, we decide what we're going to call it, right? We'll call it project A _ working _ directory or something like that. And then all of those are just $ and then the environment variable. So the code is abstracted out, and then folks set up the environment variables in their say ZSHRC or Fish or whichever terminal. So when you start up, everything's pre-populated. If that answers your question.
Essentially, you get to the full automation, and especially when you're working with multiple people, so each one, you're defining a set of environment variables that enables, once everybody set those variables, it will run no matter what. You don't need to change anything. So the path for your local folders and all those things, that's customized by environment variable. Very useful feature.
Blaz has a question. Can you merge Dockerfile and Compose up? I want to say no, unless I'm misunderstanding your question. Like the, like, correct me if I'm wrong, but like the Docker file is just a definition of how we build the image. And the Docker Compose up is how you want to instantiate a container using that image and what arguments you want to give it. So these are two separate things, unless I've completely misunderstood your question, Laz. Can you merge those two steps?
Oh,
Rami?
to run the Docker file and Docker Compose, I assume.
Like you can write a shell script if you need to, where you do the build. So you can do the Docker build, all your arguments, and then Docker Compose up and put that in a shell script. But you still have to
I think
keep
if
the
you go
Docker
to the Docker,
compose.yaml outside.
they're running a metrics of testing the Docker, so they're building the Dockers and then running a metrics with different tests on different environments, and essentially that's what they're doing, if I understand correctly your question.
Blaz, since we are over time, feel free to open up an issue and we can delve into it offline. I don't know if you get kicked out, but Rami, any concluding remarks?
First, I want to thank everybody that made the effort and joined this session. I think that both me and Roel are, in love with Docker. I think since we started, there's no other way beside Docker, at least at the moment. I know we put a lot of information. I don't expect people that we walk out of here understanding fully what is Docker, but I hope that we at least give you the motivation to go and learn Docker and dive into it and try it, because I think it's very important if you're running code and you want to make a reproducibility to use tools like Docker. So if we at least give you some motivation to go learn, so I think we achieved what we want to achieve in this session. All, do you want to anything else
Couldn't
to
have
add?
said it better myself. Just thanks to everyone who stuck with us for the last 3.5 hours. It was quite a long session. Appreciate all the questions. You know where to find us on LinkedIn or Twitter, or you have the GitHub link. Feel free to open questions in issues. If something's not reproducible, let us know. For anybody on the Windows platform, and if anyone here is a Windows user who can guide us on that initial setup, feel free to share and we can send us a PR or something and we can merge it into the GitHub. It'll help Windows folks get started as well. So we're happy for some inputs there.
Also, thank you for the organizers of the conference for making it happen and to having us on this conference.
All right. Thanks, everyone. I think we'll end the session here. Thank you.
Thank you.